Hello students, this is Miss Dalton. It's been a few days since we've had a video, so hopefully you're remembering what to do. In class we've done a few activities to describe the vertical shift and the horizontal shift of functions and specifically parent functions. So let's just kind of refresh what is happening here. When you have a vertical shift, that means that the function is going to move up and down, up or down, and it all is dependent on what is being done to the end of the function. So right here we have our function, which is just f of x. If you have a function that has something being added to the end of it, then that is going to make it move up. If you have something that has been subtracted at the end of it, that is going to make it move down. So it's just like common sense. It's logical. If you have a plus d, then that means it moves up. If you have a minus d, it moves down. Okay, well, so then when we look at the horizontal shifting, the horizontal shift means that it moves it left or right. Well, it's going to be inside the function. So if you've got a function and in parentheses you have a plus or a minus some number, so we're just going to call it C for right now. If you have a plus, it is opposite of logic. So a plus is going to move it to the left, and a minus is going to move it to the right. Okay, so if you'll just remember, on the inside of the function, it moves opposite of what you think it would do. Plus is going to move left, minus is going to move right. And then also when we look at stretching and shrinking horizontally, that's going to be the opposite as well. So we'll talk about that later. Okay, so let's move on to example 1. What we're going to have you do is I want you to write the parent function, and then you're going to list the changes that with regard to the parent function. So which way is it moving? Is it moving up, down, left, or right? So that's what you're going to write. And then I'm going to have you graph the function. Now when you graph the function, I'm also going to have you write a t-chart, and I'll explain that in just a second. So, and you're going to write a t-chart that shows what is happening to the function. Okay, so in this first function, I hope that you recognize that the parent function is a cubic parent function because you see that that exponent of 3 there. So writing down the parent function, it is a cubic, and I want you to go ahead and write down what the equation for the cubic parent function is, which is y equals x to the 3rd power. Go ahead and write that in better because it didn't come out very good. Okay. Now let's look at B. It says list the changes with regard to the parent function. So what's happening on the outside of my parent function is right here, which is the minus 2, and that is going to move it down 2. So we're going to say that it moves down 2. And then when you look on the inside of the parent function, I have this plus 1 here. Well, if it's on the inside, remember it moves the opposite of logic, and so it's going to move to the left 1 unit. Okay, now if you take out your pink notes, you'll go ahead and you'll write down the key points for the cubic function. So pause the video, get out your pink notes, and write those down, and then hit play when you're ready to go. Okay, so you have your t-chart there. These are the key points for the parent function cubic. So now what we're going to do is we're going to adjust these points based on what this new function is going to do. Well, when it moves down 2, that affects your y value. So over here on the right side of the y, and this is what I mean by writing a t-chart. So over on the right side of y, we're going to say that y is going to get subtracted by 2. Because it is moving down 2. So let's go ahead and subtract 2 to all of these y values. So we're going to have negative 10, and then we're going to have negative 3, and we're going to have negative 2, and then we're going to have negative 1, and then we're going to have 6. Okay, now horizontally, it shifts to the left 1. Well, if I'm going to shift to the left 1, that means I'm really going to subtract 1 from my x value. So I'm going to write it over here, x minus 1, and now let's subtract 1 to all these x values. So we have negative 3, we have negative 2, we have negative 1, we have 0, and then we have a 1. Now what you're going to do is you're going to graph these new values. So the ordered pairs are now going to be, for my new function, it's going to be negative 3, negative 10. So let's first graph that. So at negative 3, negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's at the very bottom, so down here. Try and make my dot. And then we're going to have negative 2, negative 3. So negative 2, 1, 2, negative 3 would be right here. And then we're going to have negative 1, negative 2. So negative 1, negative 2 would be right here. And then we have 0, negative 1, so that'll be here. And then we have 1, 6. So sorry, I didn't circle those. 0, negative 1, and then we have 1, 6. So 1, 1, 2, 3, 4, 5, 6 would be right here. And now we can go ahead and draw a sketch of what our graph should look like. So I'm going to try and hit all of these points, even though it's very hard to do. And this would be our new cubic function. Now, I always like to double check and see if it really did move in the direction that I thought it was going to. So did it move down 2? Well, remember, our key point usually starts at the origin. That the 0, 0 is a key point. So if we move down 2 from the origin, and then if we move left 1, we're going to see that we're going to hit this point right here. Draw an arrow to it. So this was our origin, and now it's over here, and you can see that it did move down 2 and left 1. Okay, moving on to example 2. The type of parent function that we have here is the log parent function, so hopefully you recognize that word log, and that pretty much makes it, it kind of gives it away that it is the log parent function. And if you remember, the log parent function is y equals the log of x. Alright, so pause your video and let's get our key points for the log parent function. Okay, so for the log parent function, we only have 2 key points, so I've put them in this t-chart. And now let's talk about what's happening to this particular function of the log parent function. So we've got the plus 2 that is on the end of the parent function, so that means it is going to shift up 2. And then if you look at the inside of the parent function, the inside is moving, it says minus 1, and if you remember, that's the opposite of logic, so that means it's going to move to the right 1. Okay, so let's do that with our t-chart here. We're first going to start with the vertical shifts. So vertical is going to change your y values. So if we're going to move up 2, then that means my y values are going to, we're going to add 2 to them. So that's going to make 0 go up to 2, it's going to make 1 go up to 3. Okay, now we're going to look at our horizontal values, and our horizontal values are going to move to the right 1, and so really if that's moving to the right 1, so the x values are going to get added 1 to them. So 1 plus 1 is 2, and 10 plus 1 is 11. Okay, so now we're going to graph these new points. So the new points, the new ordered pairs would be 2, 2. So let's go over 2 and up 2. And then our point 11, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11 would be out 1 more. And then go up 3. So that would be here. Okay, the other thing I want you to keep in mind is that the The log parent function did have an asymptote, the original one, the original log. So let me go ahead and fill that in. So y equals log of x has an asymptote at x equals 0. Okay, so if at x equals 0 there was an asymptote, well now there's going to be one. We're going to add 1 to that because of this right here, and that's going to move our asymptote to now be at x equals 1. So our new asymptote, I'm just going to abbreviate that, our new asymptote is now going to be at x equals 1. So I want you to put that on there as well. So we're going to draw a dotted line at x equals 1. And so when I draw this graph in, I want to keep in mind that there's an asymptote there. And so it's not going to touch or go through that asymptote. So here is our new log parent function. Let's just double check it. Did it really move up to and right 1? Well, if we remember, our original key point was like right here at 1, 0, and it did move to the right 1 and up 2, which would be now right here. Okay. Okay, so moving on to number 3, let's see what this parent function is. Well, if you remember, if you have a fraction and x is in the denominator, that's called your rational function. And the parent function equation for that is y equals 1 over x. So take out your pink notes and write down the key points. Okay, so here's our key points for the rational function. Notice that I also put up here what the asymptotes are. The asymptotes are at x equals 0 and y equals 0. Okay, so let's figure out what's happening to this function. On the outside of the parent function, we have this minus 2 here, which is going to make it move down 2. And on the inside of my parent function, hopefully you notice that I've got this minus 3 here. Okay, that is on the inside of my parent function because notice it is with the fraction. So on the inside I have minus 3. That's the opposite of logic, so that means it's going to move to the right 3. Okay, so let's go ahead and fill in our t-chart. Remember, if it moves down 2, that's going to affect my y values, and it's going to make me subtract 2 from these y values. So a negative 1/2 minus 2 is negative 2.5. Negative 1 minus 2 is negative 3. And then this, we'll talk about this in just a minute. And then we've got 1 minus 2, which is negative 1. And then we have 1/2 minus 2, which hopefully you can get that. That's minus 1.5. Okay, now let's move our x values. So our x values are going to move to the right 3, which means I'm going to add 3 to all of these x values. So 3 minus 2 is 1, 3 minus 1 is 2, 3 plus 0 is 3, and then 3 plus 1 is 4, and 3 plus 2 is 5. Okay, and so here are our new points. Now let's talk about what happens right here again. Well, the new, that was an asymptote right there. Well, if you remember, the asymptotes were at x equals 0 and y equals 0. Well, the asymptotes are going to be affected the same way. So this x equals 0 asymptote, we're going to add 3 to that. And so my new asymptote is going to be at x equals 3. And then for y equals 0, I'm going to subtract 2 from that, and so my new asymptote is going to be at y equals negative 2. So you can see that really this value right here is still going to have nothing there, because when x is 3, it's not going to have anything because that's an asymptote. Alright, so let's go ahead and let's graph this in. I'm going to start by graphing the new asymptotes, which is going to be at x equals 3. So 1, 2, 3, an asymptote will be right here. And then at y equals -2 would be right here. You always want to draw in your asymptotes first because it really is going to help you draw the picture. So now let's go ahead and graph these new points. We're going to have 1, -2.5. So at 1, it's going to be at -2.5. So it's going to be halfway past that asymptote. And then 2, -3 would be right here. And then at 3, there's not going to be a point. And at 4, -1, so 1, 2, 3, 4, -1 would be right here. And then we have at 5, -1.5. which would be about right here. Now if you remember what the rational function looked like when we graphed it, it's going to get closer and closer. It's going to have a curve on this side, and then it's going to also have a curve on this side. So I did my best at trying to hit those points, and so here is our graph. Okay guys, I want you to try and do number 4 on your own, and so pause the video, go ahead and do it yourself, and then when you're ready to check your answer or to check your graph, go ahead and hit play again and you can check it against mine. Okay, here's what I got. So please check your answer, make sure that it matches up with mine, and if you got it right, good job. And come to class tomorrow ready to discuss. Sorry guys, one more thing. I am going to have you do number 5 and number 6 on your whisk. So just answer number 5 and 6 from your notes packet onto your whisk. See you tomorrow.